Hi everyone, this is number 14 from the chapter 5 mylab. This is also pretty similar to number 13. It says a company that manufactures rivets believes the shear strength in pounds is modeled by N 600, 30. Use the 6895 99.7 rule to complete parts A through C. Okay, so first of all, just like the authors of the textbook says, the first thing to do is draw a picture. And so let's do that. So first of all, um, let's write this down. This notation is a little bit. Just a second here. Okay, so the notation's a little bit cryptic here. So let's talk about this notation first. So we have n means normal. So that tells you we're dealing with a normal distribution. All right. So let's write that down. This means normal. All right. So anytime you see that capital N followed by parentheses, it means we're dealing whatever it is, whether it's IQ scores or rivets or cows or whatever. The distribution is normal. Okay. And then the first number in the parentheses is always the mean of the distribution. And then the second number is always the standard deviation. Okay, and so the normal curve, so that's all you need to draw your normal curve. And so here's the x-axis, which is the shear strength. I'll just call it strength. And then draw your normal curve. And by the way, I'm not like when I'm grading tests, I'm not picky on how well you draw that bell-shaped curve. As long as it looks kind of like a bell, that's fine. It should kind of rise slowly in the beginning and then pick up speed and get more steep. And then in the center, it's going to turn and move down again. And so the center is the mean, 600. Okay, and then typically go out 3 standard deviations up and down because 99.7% of the area under the curve is within 3 standard deviations. So that's usually good enough. So 600 is the mean. The standard deviation is 30, so you add 30. So 600 plus 30 is 630. Plus 30 again, 660, plus 30 again, 690. Now, these numbers work out pretty nicely, so I just added 30 in my head 3 times. But if your standard deviation was like, something crazy like, 59.73 or something, then just get out a calculator and just keep adding that number on your calculator. And then I want to go down 3 standard deviations. So 600 minus 30 is 570, minus 30 is 540, minus 30 is 510. Okay, now according to the 6895 99.7 rule, we know we can draw a little dotted line if you like, or a solid line, up to you. We know that 68% of the rivets will have a shear strength between 570 pounds and 630 pounds. Also, according to the 6895 90.7 rule, 540 to 660 of the rivets would have between 540 and 680 pounds of strength. And then finally, 99.7% of the rivets, which is virtually all of them, will have a shear strength between 510 and 690. So let's write that in there. 99.7. All right, before I go any further, I meant to do this at the beginning. What is a rivet? So if this comes up on a quiz or a test, it says such and such things have a mean of 600, blah blah blah. And if you don't know what a rivet is, you can still do the problem without even knowing what it is, because it's 68% of those mysterious things, whatever they are, have some kind of mysterious measurement between 570 and 630. As long as you know the numbers, you can go ahead and work with it. However, it is nice to sort of visualize this a little bit more. So I did a quick Google search. These are rivets right here. They're like bolts, kind of. They're used a lot in industry. For example, airplanes are used to connect the pieces of metal together in airplanes. Sometimes rivets are used for that. I think concrete also, I think. So that's what a rivet is. And then the shear strength is how strong is the rivet. And so on our histogram here, so this tells you that 68% of those rivets are between 570 and 630 pounds strong. So you have your rivets, it's connecting two pieces of metal together. Let's say maybe there's your first piece of metal, there's your piece of metal, and your rivets, somehow holding them together. I guess it goes vertically, but well, it doesn't really matter for this question. But anyways, so this rivet can hold up to roughly on mean 600 pounds of pressure before it fails, before it falls apart. All right, that's the idea. All right, so now let's go ahead and answer part A. So part A is just multiple choice. Which picture looks like the one we just drew? So back to, so here's the original picture. And so which picture looks like the one we just drew? So first of all, there's a little magnifying glass. You can zoom in. I know these pictures are kind of small. It might be hard on your particular screen to read. And so you can click the little magnifying glass to make your picture a little bigger. All right, well, 600's in the middle on this one, but then 600's in the middle on these other choices too. So that's not going to help us. But according to our picture that we drew earlier, let's go back to it for a second. We have 95% of the rivets have a strength between 540 and 660 pounds. So let's take a look at which one that would be. So here's 95% so option A, 95% of the rivets between 570 and 630. Is that right? No, that's 570 and 630. That's 68%. So A is not the correct choice. What about B? 95% between 594 and 606. No, that's not right. It's the correct choice is option C, because I can see 95% of the rivets are between 540 and 660 pounds. If you go back to our drawing, sure enough, 540, 660. Okay, now on this particular question, notice they don't tell us exactly what the 68% mark is, but you can, it looks roughly halfway between 540 and 600, which would be 570, which is the 68% mark, 570 right there. Okay, so we got option C. Let's check, see if we did it right. We got a well done. Okay, now on to part B. Okay, would it be safe to use these rivets in a situation requiring a shear strength of 570 pounds? Explain. All right. I think it's way easier to think of the explanation yourself and then look at the choices, because by reading a wrong answer, it can get confusing. So let's just go back to our picture. The question is 570 pounds. Okay, so where's 570? Here's 570. All right, let's get another color here. All right, so there's 570. Okay, so what does this tell us? It tells us that there's a whole bunch of rivets that are stronger than 570 pounds. In fact, most of your rivets are stronger than 570 pounds. Now, we don't have to know the exact percentage on this one, but it's more than 50% of your rivets are stronger than 570 pounds. However, let's shade in yellow here. There's a percentage of rivets represented by yellow that are weaker than 570 pounds. And so if you are unlucky enough to get one of these rivets down here that maybe has a strength of like 550 pounds, let's say, and you are using them for an airplane, and the the airplane gets in some situation where it adds on 570 pounds, the rivet's going to fail. And so, who knows? Maybe that'll make the airplane crash. Or if you're building shelves, maybe it'll make the shelves collapse or whatever. And so, so do you want to take a chance? Whatever this percentage is, do you want to take that chance of a rivet failing? I would say no. I would say that's too big of a chance to take. Now, if you do want the percentage, here's a useful little trick to figure out what the actual percentage is, because I got a feeling in part C to this question they're going to ask you about this anyways. And so let's shade in this part in purple. So 68%, which I will shade in purple. Okay, so 68% of the rivets are between 570 and 630. I don't really care about that because I want to know what percentage is the yellow here, but that's a start. So you can take 100 minus 68, because remember, everything, the entire area and under the entire normal curve encompasses 100% of all the rivets. So subtract off the purple part, and you're left with 32% of the rivets. So 32% of the rivets are out here in this red part or the yellow part. Now, so that's a very useful trick, is subtract from 100 to get rid of a certain slice of that normal curve that you're not interested in. Now, another useful trick, the normal curve is symmetric, meaning this right tail, the area of that is equal to the left tail. And so you can take that 32%, which is the red and the yellow mixed combined, take 32, divide that by 2, and you get 16%. And so this area in yellow is 16%. Let's write 16% right there. And this area in red is 16%. And this area that I shaded in purple is 68%. And so you can see everything adds to 100. 16 plus 68 plus 16 equals 100. All right. So anyways, now we can refine our answer a little bit. You can say, well, if you feel like taking a 16% chance of your rivet failing, then go ahead and use these rivets on something that requires 570 pounds of strength. But if it's something where if the rivet fails, someone might die because of it, or someone's injured, then definitely don't take that 16% chance. All right. So anyway, let's go back to the questions, or to the question, and look at their answers. So first of all, the answer is no. We would not want to use these rivets if the required strength is 570. So the yes, I don't even have to read the rest of that. I know I'm not going to do a yes. C is a yes. So it's now between a B and a D. So let's look at option B. No, because 32% of the company's rivets have a shear strength less than 570. Well, no, it's not 32. We figured it out at 16%. So it's not B. So it has to be option D, process of elimination. But let's read it anyways. No, because about 16% of the company's rivets have a shear strength less than 570. So yes, no is the correct answer. So D is the correct answer. Now notice, by the way, on all of these, it says the word about 16%, about 32, about 2.5, because this 16% is not exact. The 68, 95, 90.7 rule is just a rough it's a way to get a rough estimate of the percentages. There's more precise methods, which we'll cover in other videos. All right, so D is the correct option. Let's check our answer. All right, nice work. All right. Okay, so now option C, about. Again, it says about. So 68, 95, 90% rule we can use. About what percent of these rivets can be expected to fall below 660 pounds? All right, so back to our picture, which is getting really messy, but here's 660 right here. Let me redraw this. It's getting way too messy here. So 600's in the middle. Go up 2 standard deviations. Let's go down 2 standard deviations. So 2 is good enough because it's asking about 660. Okay, so here's what I can do here. 660, that's 2 standard deviations above the mean, and so that tells us that 95% of the area is in between 540 and 660. Okay, let's use the same trick we used last time. I'll shade in the part we're interested in. Actually, we're not interested in that, are we? But let's get that area anyways. So 100 minus 95 is 5, meaning there's 5%. We can do like yellow down here, purple up there. So 5% of the rivets are in this yellow or purple area. Divide that by 2, and that's 2.5. So this is 2.5%. In this upper tail that's stronger than 660. 2.5% is the area down here, this yellow part. So altogether, 2.5 plus 2.5